A transformer has a ratio of 9:1. Find the resistance of the secondary winding with the following conditions. The primary winding resistance is 0.00391 ohm per turn and has more turns than the secondary by 1145. The copper losses in the primary is 22% less than the secondary. So, solving problems involving transformer, remember the transformation ratio, which is, let's say, K, that is equal to the secondary voltage over by the primary voltage, which is also equal to the turns in the secondary winding over by the turns in the primary, which is also equal to the current in the primary over by the current in the secondary winding. The condition says that the primary winding has more turns than the secondary by 1145. Writing that as an equation, that is n sub 1 is equal to n sub 2 plus 1145. So first, we are solving for the total resistance in the primary winding. So we need to express this in terms of n sub 2. So that is n sub 2 is equal to n sub 1 minus 1145. So let's say that is our equation 1. As we said earlier, the transformation ratio is equal to n sub 2 over by n sub 1. And in this particular problem, we have a ratio of the transformer as 9:1, which means for every 9 turns in the primary winding, we have 1 turn in the secondary winding. So that is 1 over by 9, not 9 over by 1. So let's say this is our equation 2. Substituting equation 1 to equation 2 to solve for the turns in the primary winding, we get 9 over by 8 times 1145, that is equal to 1288 turns. So solving for R sub 1, we simply multiply the 0.00391 ohm per turn times the primary winding turns, which is 1288, that is equal to 5.036 ohms. So the condition also says that the copper losses in the primary is 22% less than the secondary. So writing that as an equation, let's say P sub Cu1 is the copper losses in the primary winding, is equal to 1 minus 0.22 times, let's say, P sub Cu2, which is the copper losses in the secondary winding. Remember that another formula for the power is E is equal to I squared times R. So simplifying this, E sub Cu1 is equal to 0.78 of P sub Cu2. Let's say this is our equation 3. So expressing this equation in terms of the current and the resistance, that is I sub 1 square times R sub 1 is equal to 0.78 times I sub 2 square times R sub 2. So we are required to solve for the resistance in the secondary winding. So solving for that, R sub 2 is equal to I sub 1 squared times R sub 1 over by I sub 2 squared times 0.78. So as we said earlier, transformation ratio is also equal to the current in the primary over by the current in the secondary. So that is 1 over by 9. So we are just squaring that to replace this. That is 1 over by 9 squared times R sub 1, which is 5.036 ohms over by 0.78. Therefore, the resistance in the secondary winding is equal to 0.0797 ohms or 0.08 ohms. So I hope I helped you in this problem. Please do me a favor by subscribing to my channel. Thank you.